Hello, everybody. I am sorry that I've been out a couple days, but I avoided COVID for 18 months and it finally got me. My wife and I are doing well. My symptoms are going down slowly and surely. I just have low energy, but looking to be back next week. I appreciate some of you who shot me messages. And I hope that you guys have been doing all right. Kind of weird week again with conferences and then the 2 off-campus learning days. So I know I've been MIA. I have not really been checking on campus while I was sick, but I'm slowly starting to get back into it. I'm making this video on a Saturday for Monday because I know I'm not going to be in, but I'm hoping to be back Wednesday or Thursday, and we'll get after it. It's almost November. When you get sick, it's just a chance for you to slow down, reevaluate. If any of you are feeling stressed about math right now, that's normal. Just know that I'm gonna be there for you. We're gonna figure it out together. We're gonna push ourselves for sure, but we're gonna take it slow and we're gonna make sure we learn. Learning is the number one priority. The grade and the time that it takes is a little bit secondary. So just be flexible with me. I appreciate it, and I'm gonna be there to help you all. So today is a review, and I know it says a review guide and it says review for tests, which does mean the test is coming up soon, but I want to get in there in person and kind of see how we're doing. But it doesn't mean that the test might not be this week. Could be Wednesday. Wednesday's quick. Could be Friday. Could be a short test on Friday. So let's talk about a few key things on this. I'm going to do my best to help you, and we'll go from there. Okay, so number one, it's a different type of question, and it talks about the domain and the range of this function. And you're like, Smith, we haven't really talked about that. Well, you have a lot in Algebra 2 and college algebra. Domain and range. Remember, domain, it's basically like, it's how many x values the function can go in your function and actually work. And then the range has to do with the y values. Domain is really how far does a graph stretch left and right. And so I got an easy answer for you. Sine and cosine graphs. Remember how they go forever, right? They go forever each direction. So the domain for a sine and a cosine wave is always negative infinity all the way to positive infinity. That's always the domain. It's the range where you have to actually do a little bit of thinking. And for the range, if you think about it, it's how many y values are kind of covered by your function. So the range is going to also be 2 numbers. And the one that's going to go there is going to be whatever your lowest y value is that your graph touches. And then whatever here is going to be the highest y value that your graph touches. For example, if we did just y equals sine of x, then the highest value is 1. Remember, sine or with range, you're talking about the y values. So the highest point this graph ever touches is 1, and the lowest point that this graph ever touches is -1. So we would write the range as -1 to 1. But see, that changes if we were to put a 2 there. Now look, the highest point is 2. The lowest point is -2. So the first thing we look at for range is this amplitude. That's going to matter. The amplitude matters. But what also matters is if there's a vertical shift, because what if we put +2? Now look what the highest point is. The highest y value is 4, and the lowest y value is 0. So the range for this sine wave is 0 to 4. The domain is still negative infinity to infinity. It goes forever on the x-axis, both directions. But the range, you have to look at the amplitude, that matters, and you have to look at the vertical shift to imagine what's the highest point and the lowest point. I encourage you to use Desmos.com to maybe explore that a little bit. But let's go back to this one. And you don't have to graph the entire thing. You just use those. I'm going to use that, and I'm going to use that. And that should be enough for me to figure out my lowest value and my highest value. Here's what I mean. This is a -3 cosine wave. So I know that the lowest, it starts at -3. It ends at -3. and it rises to positive 3. So like I know that if I were graphing this, you don't have to do this, but I'm just giving you a visual, that it would go from negative 3 to 3. But then it shifted up 2 as well. So I know that this point would be up 2, which would give it a new maximum of 5. And I know that this negative 3 would also be shifted up to give it a new minimum of negative 1. So you use that amplitude and the vertical shift to figure out your range. And actually with the range, one thing I'm going to do is I'm going to take away these parentheses and actually use brackets, because it actually lands on those points, so you include those. So for number 1, and I guess I just did the one on the sheet, so I encourage you to like go back and maybe do it at the end and see if you remember, but the domain is always negative infinity, positive infinity, and the range just literally means what's the lowest point, what's the highest point. Like what's the y values that this graph covers. Okay, so you can maybe even you go to Desmos and you just change like that number and that number, because those are the only ones that matter. B and C don't matter for finding the range, so just mess around with a few and try that. Alright, number 2 I'm going to let you do. I'm just going to give you a tip and say that this could be a sine wave if you see it as this point, this point, this point, this point, and this point. You could write that as a sine wave that shifted left a couple ticks, up a tick, and I think it's stretched. Or if you saw it as a cosine wave, as 1, 2, 3, 4, 5, you can see it as a cosine wave that's shifted left 4 tick marks, up a tick, and is stretched as well. So that one has 2 answers. You can do it as a sine wave or a cosine wave, but I would just identify what your 5 points are and then go ahead and try to find your A, your B, your C, and your D. Okay, remember the hardest one of those I think for you to find is going to be the B value. The way you find it is you look at how long it took to complete one cycle. Okay, it started here. I see this as a sine wave. It started here and it took 1 pi, 2 pi, 3 pi, 4 pi. It took 8 tick marks. It took 4 pi to complete. So we go over here and we say 2 pi divided by B equals 4 pi. And we have to solve backwards for B. Remember, the B value is not 4 pi. That's your period. So you have to work backwards. So we cross multiply 4 pi B equals 2 pi times 1 divided by, so B equals 1/2. 2 pi divided by 4 pi. Okay, try that for a couple there. All right, I got 8 minutes. So 3 through 7, just test the stuff that we've been working on. What's the period? You're going to use this to find it. Is it left or right? That's going to be talking about this plus 3 pi. What is the maximum value? What does that mean? It just means how high does it go? So it's kind of like what we did up here. Finding this, that's the maximum value. So what 2 pieces do you look at to find the maximum? You look at how far it's stretched and how far it's shifted up or down. That'll help you find number 5. What's the amplitude? There it is. What's the minimum? Same thing. The minimum is going to be this. What's the lowest point? The range is basically just the minimum to the maximum y value that it goes to. So you can solve those. And now they put it all together. This will be the last one that I do on the sheet, because these are just honestly memorization. I might get to those, but let's start with this one. This one's more important. Write an equation that looks like this. Okay, that has these characteristics. It tells us the minimum, the maximum, and the period. So this right here is going to help us find the A and the D. And this right here, the period, is going to help us find the B. I don't even think the C matters. We can just leave it as blank, because it doesn't tell us that it's shifted left or right at all. Okay? So I'm just going to imagine a graph. And there's a minimum at -3. So there's some point down here. This is a cosine, so that means it'd be something else. There's a maximum at 5. So there's something there. So how far apart are those? You see what I'm saying? Like, we need to know how far apart these points are from there to there. because that's going to determine our A. So 1, 2, 3, 4, 5, 6, 7, 8. So they're 8 apart. So that must mean if we split it down the middle, it'd be 4 and 4. Because remember, it's all balanced. So if that's 8 apart, then there must be a point there and there. So it must be that that is 4 and that that is 4. So my A equals 4. My A equals 4. But there must be a vertical shift as well. Because if my A was 4, then that would be -4 to +4. But this is -3 to +5. So if normally it would be -4 to +4 as its lowest and highest, but it's actually -3 to +5, that looks like it shifted up 1. That looks like there must be a vertical shift up 1. So the B value we don't know, the C we already said doesn't matter, but the D value is a vertical shift of +1. And so I'm not really sure where that left off. I think it stopped right before I went over this. And so I'm going to end the video here. You probably didn't even notice a glitch, but I actually just talked to myself for about 4 minutes. When it comes to this portion, which this is what you did on Friday, and so I know it's still kind of new, the main thing you need to be able to do is match these graphs with their respective graphs. Okay, tangent of x. We need to know that tangent is the one that's always going up. That's this one. That one's tangent of x. Whenever you see a break in the graph, by the way, those are little asymptotes. That's for the undefined values. You can't graph an undefined value. Okay. You need to be able to know that secant of x is this one. There's a lot of ways to remember it. One way is that the secant one, this parabola gets split by the y-axis. Secant gets split. That's how I remember it. Secant gets split. Because if you can match these, then you can answer questions about them. Like it says the graphs of blank and blank have asymptotes at every whole pi unit. Which one of these has asymptotes at every pi? Looks like this has an asymptote at pi, and at -pi, and at 2 pi. And it looks like this one has an asymptote at pi. Remember, this is pi. Every tick mark is a half pi, so 2 tick marks would be -pi. So these two, cosecant and cotangent, are the two graphs that have asymptotes at every pi unit. So the key is to be able to match these, because if you can match these, then you can use these to help you. Okay? This one's secant, and it has asymptotes at different spots. You can see those. And this one's tangent. Tangent is always going up. You read a graph left to right, and tangent is always, I'm drawing arrows just to show you, it's always going up. So you'll want to refresh those. Then you got some practice of this, little unit circle practice, and then just another regular graph practice. So work through this the rest of the time. Do your very best. You can work with a partner if you need to. And then we'll get after another thing tomorrow. Good luck, everybody.